So hello everyone. Today we are going to solve Feb March 2025 theory extended theory paper. So let's start. So our first question is, using numbers only, state the percentage of oxygen in clean dry air, which is 21%. Typical operating temperatures in degrees Celsius used in Haber process, which is 450 degrees Celsius. Okay. Number of atoms in diatomic molecule, diatomic, di meaning two, so it is having two atoms. Maximum number of electrons in the second electron shell of an atom. So the second shell of every atom contains in total 8 electrons. Number of hydrogen atoms in alkane with 7 carbon atoms. So here you will have to draw, or you can simply find out by using the general formula. So we have CnH2n plus 2 for alkenes. It is having 7 carbon atoms, so it is C7H2 into 7 plus 2, which is C7H2, 7s are 14 plus 2 is 16. Hence we are having 16 carbon hydrogen atoms. Number of particles in 1 mole in standard form is nothing but your Avogadro constant, which is 6.02 into 10 raised to 23. Next is question number 2. State what is meant by the term ionic bond. So here we are always going to write this definition, that is a strong electrostatic force of attraction between oppositely charged ions. We are not going to write like metals are transferring electron to non-metals are accepting the electrons. This type of description is not accepted. Next, here they have given us a ionic compound, electronic structure for an ionic compound, where if we don't understand directly, so we should always use periodic table. Here you can see that I have written atomic number of potassium and sulfur. Also you can see that they have earlier given empty spaces. They have not even given an empty shell. Many a times students get confused that if no shell is drawn, meaning the structure is complete, but here you have to use periodic table. You can see that I have written the electronic configuration as well, which is 2881. Now 1 electron will be donated to sulfur. Okay, rest 2 shells, first and second shell is already drawn. We have to draw the third shell in case of both the potassiums. So we'll complete the shell. In case of sulfur, again I have written the atomic number. Okay, the first 2 shells are already given. Then the third shell, where it is having 6 electrons of sulfur and 2 electrons of potassium, which are being accepted. So here we just have to show it this way, 1 atom of sulfur and 1 of potassium, like that. And then you have to write the charges. For potassium it is +1 and for sulfur it is 2-. Next, ionic compounds from giant ionic lattice. Figure 2.2 shows part of giant ionic lattice structure of sodium chloride. So here actually they have already given us the half sign, that is minus. We already know that in an ionic lattice the ions are alternatively arranged, one positive and one negative. So you can see that already a negative charge is given. We will write plus opposite to that. Okay, here also it is a plus. Now opposite to the plus there will be a minus. Same, opposite to this plus there will be a minus above. Opposite to this minus, again we have a plus here. So accordingly we will write complete the structure by adding plus and minus charges. Next, state the name given to any positive ions. The name given to the positive ion is cations. Next, ionic compounds can be decomposed by the passage of an electric current using inert electrodes. State the name of this process. The name of this process we all know is electrolysis. Write the ionic half equation for the reaction which takes place at anode when molten potassium bromide is decomposed by passage of an electric current. Now here you have to understand that it is molten potassium bromide. At anode, they have asked anode, we have bromine as the product. So we are going to write the half ionic equation 2Br minus, which is going to give us Br2 plus 2E minus. For the next question, we have to name the products and state the observations at the negative and positive electrodes when dilute aqueous potassium bromide is decomposed by the passage of an electric current. Now, many a times student may get confused that above they have asked about molten potassium bromide. They might read the first sentence of the question where they have asked to find or to write the name of the products at negative and positive electrode and may end up writing the wrong answer. You have to read the questions properly. Here they have asked us to find the product of dilute aqueous potassium bromide. So in case of KBr, it is a dilute aqueous solution. So at negative electrode, that is at cathode, we are going to get hydrogen, and hydrogen is a gas, so the observation will be formation of bubbles. Similarly, at anode, because it is a dilute solution, we are not going to get bromine. Instead of that, we are going to get oxygen and water as the product. Again, oxygen is a gas, so the observation will be formation of bubbles. Next, question number 3. The halogens are a group of elements in the periodic table. Chlorine is a member of this group. State the group number of the halogens. Halogens belong to group 7. We are going to write group 7 here in Roman numerals because group number is written in Roman numeral. Next, state how many halogens are there in this group. For that, we will have to refer periodic table. We have to find the number of halogens in this group. This is our group 7 and we have 1, 2, 3, 4, 5 and 6. Six halogens. Suggest the identity of the halogen which has the highest density. For group 7, as we go down the group, the density increases, and hence tennessine is the one with the highest density. The one which is most reactive in group 7, as we go down the group, the reactivity decreases, and hence fluorine is the element with highest reactivity. State the name of negative ions formed by halogens. So when halogen form an anion by accepting electron, they are named as halide. State how many occupied electron shells there are in a bromine atom. For that, again, you have to refer periodic table. You have to check that bromine falls under which period to find out the number of electron occupied shells. This is our first period, second period, third period and fourth period. So bromine belongs to fourth period. So there are total 4 electron filled shells we have. So we'll write 4 here. Name the noble gas which has same electronic configuration as Br minus ion. Now bromine is having atomic number 35. Again, bromine is having 7 electrons in its outer shell. Now when bromine accepts one more electron, the 35 electrons become 36, and which resembles to the next noble gas, that is krypton. So we are going to write krypton here. Next, complete and balance the ionic half equation for chlorine and iodine. So here chlorine and iodine are reacting. Okay, so it is, we are just have to going to balance it. Now you can see that we have 2 here, so we are also going to write 2 here, and then we have 2 chlorine atoms. So when chlorine accepts electron, the bond between it breaks down and becomes 2Cl minus. That is how we are going to balance it. Explain why this reaction is defined as a redox reaction. Give your answer in terms of electron transfer. So here we have to explain the answer in the terms of electron transfer and not as reduction and oxidation in the terms of oxygen. So here you can see that iodine has converted to the iodide has converted to iodine. Okay, so it has lost its electron, so we'll write I minus loses electron. And chlorine atoms, chlorine molecules, you can say, have a negative charge now, hence it has accepted electron, so chlorine gains electron. That is how we are going to explain. Give the color and state of iodine at room temperature and pressure. So color of iodine is gray black and it is in solid state. As I told you that as we go down the group, the physical state also changes from gas to solid. Question 4. Carbonyl chloride is manufactured by reacting carbon monoxide with chlorine. They have also provided us with the equation, and you can also see that they have given us the delta H value here, which is minus 105 kilojoules per mole. Now the delta H value tells us about the type of reaction, type of forward reaction. So the forward reaction here is exothermic. They have mentioned that the process is taking place in a closed system and an equilibrium is reached. The conditions for this process is 200 degrees Celsius and 200 kilopascals. Explain what is meant by the term closed system. So closed system is something where nothing can enter or leave from the system. State what the symbol delta H represents. So the symbol delta H represents that it's the enthalpy change, the energy change of the system. State how the value of delta H shows that the forward reaction is exothermic. So as I told you that the delta H value is having a negative sign, hence it tells us that delta H is exothermic. If delta H had a positive sign, then it would be an endothermic reaction. Deduce the value of delta H for the reverse reaction. Include a sign in your answer. So the forward reaction is having minus 105 kilojoules per mole value. So the backward reaction will be endothermic and hence it will have exact opposite value, which is plus 105 kilojoules per mole. For the next question, they have asked us different factors that are going to affect the concentration of COCl2 at equilibrium. You are required to write the words strictly given here, that is increase, decrease or no change. So first question is temperature is increased. Now here you have to pay attention that the forward reaction is exothermic, okay, which releases energy, and you are also increasing the temperature. Hence it is going to favor the backward reaction and the concentration of COCl2 is going to decrease here. For the second one, CO is added. Carbon monoxide is a reactant here. If you increase the concentration of a reactant, the yield of product is going to increase. So we'll write increase here. The pressure is increased. Whenever the pressure is increased, we always have to check the number of moles first. So in the reaction, you will check that there is no stoichiometric coefficient written in front of the reactant. So it is 1 and 1. So the total here is 2 moles. And for COCl2, there is nothing written, so it is 1 mole. Now, whenever pressure is increased, the equilibrium always shifts where there are few number of moles of gas, and it is towards the product side, which is the RHS side. So equilibrium will shift to RHS, and hence the concentration of the product COCl2 is going to increase. Last is the catalyst is added. So whenever we add a catalyst, there is no effect on the position of the equilibrium or the concentration of the equilibrium, and hence there will be no change. Catalyst is always used to just increase speed of reaction. Next, here they have given us an equation. Also they have provided us the delta H value. Okay, now they have provided you with the bond energy values of all the bonds given here. So we have to find the bond energy value of C double bond O. Okay, so first of all we are going to find the energy required to break the bonds, because we have all the bond values, bond energy values given here. So we have C triple bond O, which is just one bond, so we'll write 1075, and we have one bond of CL. So again we will write 240. We will just add that, which is going to give us 1315. for the energy released when the bonds in carbonyl chloride form. So here we are just going to write the equation, that is delta H is equal to bonds broken minus bonds formed. We are just going to shift bonds broken on the left hand side, and hence we will just put the value which is already given to us, which is minus 105 minus of 1315 is equal to minus BF. The minus minus gets cancelled and we get the value 1420. Now calculate the bond energy of C double bond O. So we have 1420 minus, we already know the value of CCl bond, which is we have two bonds and it is bond energy value is 340. So we are just going to subtract it. So two bonds into its bond energy value, which is 340, that is going to give us 740. So the value for C double bond O bond energy is 740. Next, here it is a covalent structure which is being given, which you have to complete by just writing the electrons. They have mentioned that you have to use a dot and cross diagram. Okay, now first we will go for carbon. So carbon is having atomic number 6 and its electronic configuration is 2, 4. It is having 4 electrons with it. Okay, so when we are bonding it with chlorine, chlorine requires just 1 electron. So carbon is going to donate 1 electron here. I'll just show it once again. So carbon is going to donate 1 electron each to chlorine. Okay, now as carbon has donated 1 electron, chlorine also needs to donate 1 electron. It has to share 1 electron here. Okay, now chlorine is having atomic number 17, which is 287. Out of its 7 electrons, it has already shared 1 electron. Okay, so how many more electrons are remaining? That are 6, which we have to show on its shell. Similarly, on the other chlorine shell, we will show 6 electrons. Now it comes to oxygen. So oxygen is having its atomic number as 8 and its configuration is 2, 6. As you can see that chlorine requires 2 more electrons to complete shell. Okay, so carbon will share 2 electrons with oxygen. Okay, and oxygen will also share 2 electrons with it. Out of 6, oxygen has shared 2 electrons, so there will be 4 electrons on the shell of oxygen. You can always use a periodic table whenever you are going to write the electrons in case of ionic structure or a covalent structure. Question 5. Manganese is the element with atomic number 25 in the periodic table. Calcium is the element with atomic number 20 in the periodic table. Complete table 5.1 to show the number of protons, neutrons and electrons in manganese 55 atom and Ca2 plus 42 ion. So because they have already given us the atomic number, there is no need to refer periodic table. So the proton number will be same, which is already given here. So for manganese it is 25 and for calcium it is 20. That is nothing but the atomic number. For neutrons you will have to subtract 55 minus 25, which is going to give you the neutron number. Same in case of calcium, you will have to subtract 42 minus 20, which is going to give you 22. In case of electrons, because manganese do not have any charge, the proton number is always equal to electron number, so we'll write 25. In case of calcium, you can see that it is having a charge which is 2 plus, meaning calcium has donated 2 electrons. Okay, so 20 minus 2 will give us 18. So the number of electrons in calcium is 18. Next, manganese forms several oxides. The formulae of some of these oxides are shown. Suggest why manganese is expected to form colorless oxides. Because manganese is a transition element. Okay, So all the transition elements, you can consider some of them, mostly they form colored compounds, and that is why it is also going to form a colored oxide. State which other property of manganese is shown by the formation of several oxides. You can see that manganese oxide is having different formulas here. Okay, it is because of the different oxidation states of manganese, it is having different oxidation, different manganese oxides. So here it can represent the variable oxidation state property of the transition elements. State the formula of manganese 2 oxide. So manganese 2, meaning it is in a +2 state, so I'll write +2 here, and oxygen is also having oxidation number -2 here. The +2 -2 gets cancelled, and hence the formula becomes MnO. Mn3O4 is found in an ore of manganese. Manganese metal can be extracted from Mn3O4 using aluminium as the reducing agent. So what is the definition of a reducing agent? So reducing agent is agent that itself gets oxidized but reduces the other substances. Okay. Next, complete the symbol equation by inserting the formula of missing product and balancing the equation. So we are going to balance it. Now, when Mn3O4 reacts with aluminium, it is going to form aluminium oxide, as aluminium is more reactive than manganese, so it will form Al2O3. Okay, and now we have to balance the equation. So here first we will balance it. First we'll balance manganese. You can see that Mn3 is given, so first let us write 3 in front of manganese. Okay, next you can see that we have 2 aluminium here, so we are going to write 2 Al in the product side as well. Now is the time for balancing oxygen. You can see that we have 4 oxygens in the reactant side and 3 oxygens in the product side, but we don't have any such number which is going to balance product side oxygen 4. We will have to find a common number between 4 and 3, and the common number is 12. So somehow we will have to make the oxygen as 12. Okay, for making the oxygen 12, in case of reactant side, 4 is already given, we will have to multiply it with 3. So 3 into 4 becomes 12 here, and in case of aluminium oxide, again 3 is already given, we will have to multiply it with some number that will make it 12. So we'll write 4 here. Okay, so it is 4 3s are 12. Now when we balance oxygen, again the manganese, aluminium, they get disbalanced, so we are just going to remove this number from here. Okay, now 3 3s is 9 aluminium, so we will have to write 9 here, and in case 9 manganese. In case of aluminium, you can see we have 4 2s are 8 aluminium, so we are going to write 8 in front of reactant aluminium. Okay, this is how we are going to balance it. Next, manganese oxide reacts with dilute hydrochloric acid as shown in the reaction. They have also provided us with the equation, that is MnO2 plus 4HCl is going to give us manganese chloride plus 2H2O plus chlorine. Calculate the volume of chlorine gas formed in centimeter cube when excess of manganese oxide reacts with 50 centimeter cubes of 0.200 mole per dm cube of HCl. Here volume is given to us and concentration is given to us, so we are going to use the formula N is equal to C into V upon 1000, which is 0.200 into 50 upon 1000, that is going to give us the answer 0.01. Next, reduce the number of moles of chlorine formed. For chlorine, we don't have any value. We have just found the moles of HCl. So we are going to take ratio of HCl is to chlorine, which is 4:1. So we'll write HCl is to chlorine. For hydrogen chloride, it is 4. And for chlorine, there is no stoichiometric coefficient, so it is considered 1. For HCl, I have just found the moles, which is 0.01, and here it is x because we have to find. We will cross multiply. So this becomes 0.01 into 1 upon 4 is equal to x. So the answer becomes 0.0025. Finally, we have to find volume of chlorine formed. So volume is equal to moles into 24 dm cube, but because I have to find my answer in centimeters cube, I am going to multiply 24 into 1000. So it is moles into 24,000, which is 0.0025 into 24,000, which is going to give me 60. You can either first find the answer and then multiply it with 1000, or you can directly use 24,000. In such questions, you have to first check whether the answer is asked in dm cube or in centimeter cube. Many of you get confused. You just simply multiply it, find the volume, and just write it down without being observing whether the answer is asked in centimeter cube or dm cube. Next, describe a test for chlorine gas. So chlorine gas always bleaches the litmus paper. So either we can use a damp red litmus or a blue litmus paper, which is going to get bleached. For the next question, explain in terms of collision theory why decreasing the temperature decreases the rate of reaction. Now, in most of the papers, they always ask about increasing the temperature, but here you have to read the question carefully that they have asked about decreasing the temperature that decreases the rate of reaction. So, the first point will be that the particles are going to have less kinetic energy. There will be less frequent and successful collisions, okay? And many of you, they just write the same point again, that the speed of the particles is less and hence there is less successful collisions. But the third point here will be there will be few number of particles that have energy greater than activation energy. That is the third point which you have to include. Question 6. The structural formula of two compounds A and B are shown. You can first see that the structure of A and B is alkene. Okay. A and B are members of same homologous series. Give two reasons why the structural formula of A and B show they are members of same homologous series. So as I told that they both are alkene, the common thing which they both have is a carbon-carbon double bond. And definitely if they belong to same homologous series, they will have the same general formula. Explain why A and B are both hydrocarbons. They are hydrocarbons because they contain hydrogen and carbon atoms only. Write the symbol equation for the complete combustion of A. So here A is nothing but 3 carbon compound, which is propene, which is C3H6. For combustion reactions, it always react with oxygen. And the products formed here are carbon dioxide and water. Once you write that, then you have to balance the equation because it is for 2 marks. So, how are you going to balance the equation? So we have C3H6 plus O2, which is going to give us CO2 plus water. You have to remember that whenever there is a combustion reaction of alkane, alkene or alcohols, they all give us the same product, that is carbon dioxide and water. So now, here if you observe, you have 3 carbon atoms. So first I'll write 3 here. Okay, you have 6 hydrogens. So you have already 2 here. I will multiply 3. So I'll write 3 here. Now, here hydrogen and carbon are being balanced. Now I have to balance oxygen. So 3 into 2 is 6 oxygens. And I have 3 oxygens, which is total 9. Okay, Now, on the left hand side, that is the reactant side, I have only 2 oxygens. I don't have any such number which, when multiplied by 2, will give me 9. So, I will have to find some common number between 2 and 9, which is 18. So, I'll write 9 in front of oxygen. Okay, now it becomes 9 into 2 is equal to 18 oxygens. So I will have to again change the stoichiometric coefficients which are written in front of CO2 and H2O. So how I'm going to balance it out? Here, to make it 18, I will have to write 6 in front of CO2. So 6 2s is 12. And to make it 18, I require 6 more oxygen atoms. So I'll write 6 in front of H2. Okay, so there are 6 oxygens plus 6 is going to make it 18. Okay, now as I have 6 carbon atoms, here in my reactant side I have C3H6, so I will have to multiply something with 3 to make it 6. So I'm going to write 2 here, and hence my whole equation is balanced now. So I have 2 3s are 6 carbon atoms, and I have 6 carbon atom in the product CO2. I have 2 into 6, which is 12 hydrogen atoms. I have 2 into 6, which is 12 hydrogen atoms, and oxygen, so we have balanced earlier. Next, deduce the empirical formula of A. So we'll see what is A. A is 3 carbon atom compound, so we are just going to count the number of carbon atoms and hydrogen atoms, which becomes C3H6. I'm going to simplify it further. So 3 1s are and 3 2s are. So C3H6, and here we have C1 and 2. Okay, so the answer becomes CH2 here as well. Yeah. Next, name the compound B. So B, we are just going to number the compound first. Okay, you have to always check the lowest priority to the double bond. So either you number it from left to right, or you number it from right to left. 1 2 3 4. You get the same number 2 3 2 3. Okay, so the double bond comes at the second position. We have 4 carbon atoms, and we know that it is an alkene, so we will write the prefix first, which is but, the double bond position, that is 2, and the type of compound, that is alkene, so the name ending becomes ENE. A structural isomer of B is a member of same homologous series. Draw the displayed formula of the structure isomer of B. So we have just written the name of the compound B, that is but2ene. We have to draw a displayed formula of another isomer. So here we just have to change the position of the double bond, and hence it will become but1ene. So let us draw that. We will draw 4 carbon atoms first. Now, because we have to put double bond at first and second carbon atom, we will put that, and now we are just going to complete the structure with the remaining hydrogens. So it will be 2 hydrogens. For the second carbon, it is already having 3 bonds, so we'll write 1 more hydrogen here. For the other 2, we are going to write remaining hydrogens. This becomes the displayed formula of the isomer. Next, compound B reacts with aqueous bromine at room temperature to form product C. The equation is shown. So they have already given us the equation that how B is going to react with bromine to form the product. Now, state why this is addition reaction. You can see that only one product is being formed here. There is no other product. So only one product formed. Describe the color change in aqueous bromine during this reaction. So bromine is already orange in color, and when we add it in an alkene, it goes colorless. So it is from orange to colorless. Name product C. We are going to name the product C here. So first let us number it. So we'll number it from 1, 2, 3, and 4. That is from right side. We'll also number it from left to right. That is 1, 2, 3, and 4. Now if you see here, when you number it from this end, that is right to left, you get the bromine at second and third position. And when you number it from left to right, again you get bromine at second and third position. Okay, so you can go with any numbering because it is getting the same number. So we'll write the position of bromine first, which is 2 and 3. We have 2 bromine atoms, so we'll write dibromo, and it is 4 carbon atom compound, so butane. Under certain conditions, 1 mole of B reacts with oxygen to form 2 moles of carboxylic acid D. They have also told us that carboxylic acid D has 2 carbon atoms. So draw the displayed formula of carboxylic acid D. Now we know that carboxylic acid contains 2 carbon atoms. So we'll first write the functional group of carboxylic acid. While drawing the structure, you always have to remember that in carboxylic acid, the functional group of carboxylic acid contains 1 carbon, and you have to always consider that carbon in the main parent chain. So we have the carboxylic acid here. Okay, and 1 carbon is done. We just require 1 more carbon atom here, so I'll just add 1 more carbon atom. Complete the structure by adding hydrogen. Here becomes the structure of ethanoic acid that contains 2 carbon atoms. So name of this compound D is ethanoic acid. We have to just complete the equation here. So they are talking about the same reaction, that 1 mole of B is reacting with oxygen to form 2 moles of carboxylic acid. So it reacts with oxygen. So we are going to write O2 here, and it is forming 2 moles of ethanoic acid. So we'll write 2 CH3 COO